Okay, it's time to show you the fun of using the unit circle. So this is how I like to do it. I like to break it up in one trig function at a time. So if I say what's the sine of angles, I usually call it sine of theta. We use theta as a common angle reference. Sometimes they throw x in there too, but I think it's confusing. But sine of theta is a nice way to look at it. We like to think of sine of theta as actually your y coordinate in this, and here's why. It's not a mystery. So what's going to happen is when I say sine of 30 degrees, what you're actually going to do is find out where 30 degrees is located. And now I can draw the triangle in there, but what we start to do is we start recognizing the size of angles by how they're oriented in there. So that's 30 degrees. This one here is 60 degrees, and so if you'll notice, I have a little spot in here on the circle where you have a little place like square in a circle. Usually I say, hey, in the circle, why don't you write in the degree for that particular line of it, and 60 here. And I bet you can guess what goes down the middle here. What kind of angle would fit right smack down the middle? Can you guess what that one would be? Here's your 45-degree angle. Splits the angle in half. And if you go straight up, this is 90 degrees. We think of this as being straight up as we're actually looking at, remember, the size of these keeps growing. And if you go all the way to that size right there, that's 90 degrees. Okay, so it's just a little exercise in how this works. I'll put those triangles in there. Can you imagine these right triangles being in here? I'll try not to overlap numbers. Okay, the way those triangles work within there is that because the hypotenuse of each of these triangles is 1, let me highlight them. This one has a length of 1. Okay. Did you forget the lengths of the sides on there? That'd be normal if you did, but I'll go back in there with a different color, maybe green, and remind you if that's 1 and the 30, 60, 90, this is a half. Okay. And then the next one, when you turn it on the 30, 60, 90 on its side over here, that side that I just highlighted in green, let's do all the heights in green, that green right there, that's the square root of 3 over 2 because it's it's on the other side. I'm going to go off to the side here. I can show you one of those 30, 60, 90s on its side. So here's one laying flat, where the half is the vertical side of it. But when I lay it tall-wise, like this, then it's the square root of 3 over 2. That's the height, and the half is on the bottom. Okay, so that's what we're talking about, is just turning these on its side and kind of measuring how high it is. And what's interesting, the way they fit into the unit circle, is then that's where the y-coordinate is always where so I didn't finish this last piece of it. I didn't actually, if you can just think of the y-coordinate just being the up on top of there, I'm just going to do a half in there, square root of 3 over 2, stuff like that. And if I go to the 45, do you want to remember what those are? Do I need to draw another picture for you? I imagine you got it tucked away in there. Do you remember the hypotenuse is 1, then it's 1 over the square root of 2 up, or for its height. There we go. You get that right? Yeah. Look at that. That's slick. So we're just labeling those heights inside the unit circle. And those end up becoming really important because when I take the sine and cosine in those locations, we're going to find out something kind of cool. So I'm going to delete the stuff that's on here. I just wanted you to get a sense of how I labeled this. And now I can't put a triangle at the 90-degree angle up there, but I do know what the height is. Like just offhand, I can put it at that it's 1, because you can guys tell it's up to the top of the unit circle, and a unit circle has radius 1. So let me clear all this off and put in a new unit circle. Okay, so when I put those triangles back in here real nice and clean, I'm going to label all the sides this time so you can see it. This is the hypotenuse is 1. 1/2 is this leg, and square root of 3 over 2 is this one. What I could do is I could say, hey, just like we always have, this is 30. If I say, what's the sine of 30, you're going to go the opposite over the hypotenuse. And you're going to go 1/2 over 1. And that would be called evaluating, just like we did on the other page. Sine of 30 degrees would be a 1/2 over 1, which is just 1/2. Did you remember what we labeled that height? Do you realize that we just took the up position, or the y-coordinate there, and divided it by 1? That happens every time when we do these unit triangles. The hypotenuse is always 1, so every time you do opposite over hypotenuse, it's just the opposite, or the y-coordinate. So when I do the next one, it's a 45, 45, 90 triangle. So I'm going to clear everything out again so you can kind of see the cleanliness of this. And what you'll see is, if I do another one like the 45, 45, 90, and I say, hey, what's the sine? Remember I said I'm just going to do a bunch of sines today. This is the height of 1. This would be 1 over the square root of 2, 1 over the square root of 2. If I say what's the sine of 45, you're going to go opposite of our hypotenuse, 1 over the square root of 2 over 1. You realize that opposite of our hypotenuse is always going to be something over 1. And depending on which triangle you're using, the 45, 45, 90, it's 1 over the square root of 2 over 1. If you're doing, like I did just a minute ago, that 30, 60, 90, and I was doing a half, so let's just put that back up there. So just think of when you're taking the sine of an angle, you always end up doing that opposite side, the 1/2 over the hypotenuse. So if I do the next one again, if I do 45, we just did the opposite side, which is 1 over the square root of 2 over 1. Now if you do this 30, 60, 90 here, that's just going to be square root of 3 over 2 over 1. Remember what triangle I'm drawing that from. So it ends up that we really just, for the sine of the angle, it's just going to be that height represents it. That's really the shortcut to this unit circle, is that we realize that the sine is the opposite over the hypotenuse. Hypotenuse is 1, which means the sine is just the height at that particular angle. So if I can just imagine, it's just about that height at the respective angle that gets you there to that point. Okay, and so that's actually the miracle of the unit circle, is that you just memorize, you know what, sine is always going to be the height, or that opposite side in those triangles, and you kind of memorize them because you know where they come from. Remember, they're 30, 60, 90, 45, 45, 90. And I kind of do it by proportion. You know what this one is. It's the smallest one of the bunch. It's a half. Okay. You know what that 45 is. The 45s are always 1 over the square root of 2. So you start making patterns out of it. And then that long leg at that 60-degree mark is the square root of 3 over 2. So that ends up being, that's how we do sine, is we just say, hey, look at that. The sine of, now that's 60 degrees that I'm pointing to right now. The point is 60 degrees up. The sine of 60 degrees is going to be the square root of 3 over 2 over 1. We just write the square root of 3 over 2. Then that y value right there is going to be the sine of 45 degrees is 1 over the square root of 2. And then this one right here is going to be the sine of 30 degrees is 1/2. And that is the end of that. That just gives you the idea how sine is. Now, if you want to just talk about, does this pattern continue if I do triangles the rest of the way around here? It does. It doesn't matter how you rearrange those triangles inside there. I could face them this way, and the opposite over the hypotenuse. That's still a 30, 60, 90 triangle. It's just backward facing. And so if I say, what's the sine of that angle? You would just say, hey, looks like one of those 30, 60, 90. That's the long leg on a 30, 60, 90 right there. That's the square root of 3 over 2. Because you know how tall it is. You recognize the triangle it's from. You'd be right. So that ends up becoming the game that we play, is that we just go in, actually, and if you want to evaluate the sine of a particular angle, all you have to think of is go to that angle, wherever it is. Now what's interesting is we start thinking these angles differently. That brings on our next video, is how do you circularly think of angles? And if you haven't done this before, we actually think of these points along here as being at particular angles. Like this first point here, there's 30, that point's at 45, this one's at 60, 90, and we keep rotating. This actually is 120, 135, 150, and 180 is facing the exact opposite of where you started, which is 0. And we do this, what's called a counterclockwise rotation. But as we go along there, every time we do sine of an angle, all we do is, hey, how high is it? And the answers are either 1/2, 1 over the square root of 2, square root of 3 over 2, 1, and then square root of 3 over 2, 1 over the square root of 2, and 1/2. It just constantly saying those same numbers over and over and over again. And where they come from are those triangles that you know of. This is just an efficient way to do not just 30, 60, and 90 angles, but all the multiples of 30, 60, and 90 around further and further up to 360 and beyond. Okay. All right, that's the end of this one. On to the next one.